makes the most advanced air quality monitors in the world. We detect all the major components that link up that measure air pollution, which we break down into three main categories. The first are comfort metrics: pressure, temperature, humidity. The second are a wide range of indoor and outdoor chemical pollutants. And then finally, particulate matter: PM 2.5, PM 10. We link that back up in real time with our servers, provide information, analytics, and then above all else, simple, context-relevant steps that you can take to start improving your air quality. So air quality is an extremely important global problem. Just as we believe that people want to work out, people would like to eat healthily, we also believe that people should want to breathe healthy. And yet it's appalling that greater than 50% of the world's population breathes air that's 250% worse than what the World Health Organization outlines as safe to breathe. And this is simply because we've seen sort of a bifurcation of sensor technologies that are out there. On one end, you have really expensive sensor solutions that cost quite literally close to $10,000. On the other end, you have consumer solutions that really just provide more fluff than meaningful data. So we hope to sit right at the middle of those two things to provide advanced indoor air quality monitoring for commercial buildings. And so what this system entails is advanced networking, leveraging a lot of proprietary technology that I'll get into in a minute. But we can create mesh networks and then create an online dashboard where people can see in real time what's going on, an instant alert if something's wrong, and then again, simple steps that you can take to start improving your air quality. So this is some of our affiliate networks and our founding team. Our CEO, Brian, and I met first through an industrial engineering course over at UC Berkeley. Brian had come from a chemical engineering background over at Caltech, and I myself came from a software background. So we're discussing ways that we could essentially combine those two things. New advancement in software, a lot of artificial intelligence and machine learning, with new chemical engineering and chemical sensing technologies. Really the marriage between those two. And 2 years later, that's what this looks like. Through a lot of amazing partnerships with Shenzhen Valley Ventures, Basic VC, Han and Vincent, and then obviously Techcode as well. We've reached a point where we're at a sort of inflection point for our company. To date, our manufacturing capabilities have always been less than what our customers' demand has been, meaning we sell out of every single device that we can make. But now we've finalized the parts sourcing, the tooling, everything else, just so that when we start the process, we could deliver a device in a very timely manner, which for us is a really, really exciting time period. Again, just scaling up to be able to meet demand. So this is a full list of everything that we detect, around 22 different things in total, and we detect them at world-class levels. So what the United States outlined as the threshold for safe or not safe to breathe, at the very minimum, we go below that threshold, which is the important values to be sensing. So the way our technology works and how we've actually built this. First, we start with a proprietary chemical sensing technology. So we embed polymers with conductive materials, mainly like carbon nanotubes, carbon black, things like that. And so once a chemical comes into contact with the polymer will swell, and then we see a change on our circuit that's concentration dependent and is entirely an equilibrium-based reaction. We combine both our proprietary sensors as well as third-party sensors into an array, and then measure the resistance change across the entire array, and then have a whole suite of artificial intelligence and machine learning algorithms that live on the server that help us to make sense of this data. So for every single device, we collect around 500,000 data points per day. And then we have a suite of algorithms that sort of networks and goes over the top of those. So for example, if we see sensors ABC react to XYZ percentages, then we can be very, very specific that it is this chemical at this concentration. And so what that's enabled us to do is our sensors are performing at absolutely world-class levels. In total, our sensors beat out approximately $20,000 worth of equivalent sensors. We've got some really great partnerships with these guys.